what we want to take a look at is one that everybody should have down.
Stop the bleeding.
That's for
You
Nolan.
guys need these?
No,
No, Nolan's not going to be wrestling, so we'd be okay on that.
Oh, so I could have saved the money?
Yeah.
They're 10 pounds of ice cream.
All right. So, atomic radii. I'm going to abbreviate some of these guys. So, let's do this. Just want to make, I got limited space in which to do things. So let's do this. Let me go ahead and down in this middle box, I'm going to put atomic radii. There's a space where on the back of your review that you can actually put this chart, and then you guys can use this chart to help you out. What was the other one I had? Electron Affinity? So let's abbreviate this. Is AR. Okay, that's supposed to be an A. IE. Okay, electronegativity, we'll just put ELEC. For density, a D. And then for electron affinity, EA. How's that sound? Does that make sense? Okay, so let's just go through the trends. So AR, atomic radii, what does it do as you go across a period?
Increases.
Atomic radii does not increase going across. It decreases. Size of the atom decreases. A lot of you guys use that as a rationale when you guys did your trends, right? The reasoning. Okay? So going down, what does AR do? What does it do? Increases in size. So as I go down the group, atomic radii increases. Any questions on that? Atoms get smaller as you go across, and they get bigger as you go down. Hello? Uh-huh, sure can. Ellie, you need to go down to the office. Okay? Next one, ionization energy. So IE going across, what happens to it? Does anybody have information on that? Did anybody do period trend for ionization energy? I don't think so, right? So, here, let me ask you a question. I bet you guys can figure it out. The atom gets smaller going across. Will the ionization energy to pull out electron get greater or get easier to pull out electron? What do you think?
Easier.
Greater. Why?
Because the bond is stronger.
Because the force between the electron and the nucleus is a lesser distance, which creates a greater force needed to pull it out. Does that make sense? Okay, now Bennett would have got it because I think he did ionization energy for the group. And so he understood that's the opposite as you go down the group. So ionization energy going across will increase. But ionization energy when you go down, Bennett, decreases. The opposite reason. The electron gets farther from the nucleus, so it becomes easier in which to pull it out. Okay? Now we've got 3 more to deal with. How about electronegativity going across? Who had that one? Period. Period trend for electronegativity. What happens to it?
As you get farther to the right, it increases.
It increases, right. So electronegativity increases. But going down, somebody have that going down? It decreases. You guys see a pattern here?
See inverse relation.
Yeah, it's inverse. Very good. So far, everything's been opposite. Going across, it does this. It's the opposite going down. So then, the next one as we go across is density. Okay? Now, density does not follow a trend. So I'm not going to do one going across, because what happens with density, I think Brody, you guys had this one, right?
Yeah.
It increases, and then when you get into different states of matter, like the gases, it decreases because you got a bigger volume, space that they take up. So I'm not going to write that one down because it goes up and then down. All right? So I really can't show that with arrows. But I can show density going down. What does density do going down a group in general? It increases, right? The density gets bigger. And then our last one, electron affinity, which means the ability of an atom to get an electron, is not very good going across. It's not a very good one, because I think, for example, I think Caitlin's group had where they were zeros. Did somebody else have electron affinity where you talked about zeros? What's that? You did, but I mean, you came across that too, right? And it showed that electron affinity for this group was zeros. That's group 2. It also showed that this last group was zeros. Electron affinity. Okay? And I'm about done with this, but as you go across, the electron affinity increases unless you hit the zeros. Okay, so as you go across, it usually increases, but when you hit the zeros, of course, it's going to go down. So electron affinity increases going across. What do you think it happens when it goes down? It decreases. I put extra there and didn't follow my rules down below. So it decreases. Okay? Now there's zeros. Does anybody know why those are zeros? Caitlin?
Because they're all full of, they don't have any more room.
Yeah, their sublevels are full. So if you look at this sublevel for this group, they're all full. It's kind of like Thanksgiving dinner, right? You're full. Can't eat anymore. You're done. Okay? All right? Some of you are, when you get down to these and you got one left, these are the highest electron affinities is this group, because you got one left. That's kind of like, yeah, I got to have dessert. Duh, I got to have dessert. Even though I'm pretty full, I can't go away from not having dessert. Okay, so questions on just the trends in general. Everything going across, okay, increases except for atomic radii. Everything going down is going to decrease except for atomic radii and density. So if I give you this worksheet, and I'm going to have you do a couple of these. Before you go, I know Wrestler's going to get out here in a second. But we're going to do 2 of these real quick so they can understand kind of what... These are the type of questions I'll ask you on the quiz on Tuesday. Exactly like these. They won't be any different. So if you can handle these, then you can handle what questions are going to be on the quiz. So, before we go, we got a minute. Let's look at A, 1A. So, we find these on the chart. We find selenium. And selenium is right here. Here's selenium. Okay? And then calcium is right here. Okay, as you go across, what happens to the size of the atom? gets smaller, right? So which one's larger? Calcium. Make sense? Calcium's larger than selenium. Let's take not B because we want to take a different one. Let's look at F. Which one has a smaller electron affinity? Sodium or potassium? Here's sodium. Okay, here's sodium. Here's potassium. What happens with electron affinity as you go down? It decreases. So which one's smaller? Potassium. Make sense? Okay. So you will do that for Monday. Okay? What I'd like the rest of you to do is just to fill out what you can on your review with the boards. And then we might take the last 5 minutes. If there's one I need to show you a little bit more information, we can, and we can finish it up on Monday, everything. Kind of put everything together on Monday. Make sense? Hey, good luck, guys. We'll be watching you on track wrestling, right, guys? Everybody will be watching how they're doing. You guys know how to use track wrestling, right? You do?
Well, you blew it.